Looking at humanitarian supply chains is an important topic because if you look at the news today and you see how people are being affected by COVID-19, and even think back about how people are being affected as a result of hurricanes, and particularly Hurricane Katrina, which is one of the most devastating hurricanes we've had in the past 10 years or so. We see how people need to get the things they need: food, shelter, water. Those are three important things that people need in order to return back to what their life was like prior to the specific event. So when people don't get the things that they need, there's potential loss of life. And I like the fact that the research that I'm looking at tries to help organizations figure out how to get the items, those most needed items, to people at a most critical time in their life. And it's a very interesting topic to look at. And I love that it brings together the important things that I learned as a student in industrial engineering, and being able to develop these mathematical models or computer-based models that are representative of the operations of the particular organizations engaged in humanitarian efforts. The type of models that the students that I work with build some of them are statistical models. So we would try to, for example, predict how many donations an organization like a food bank might receive. We also develop something called stochastic models, which are models that incorporate uncertainty. So the probability of receiving, say, 20 pounds of food or 200 pounds of food on a specific day at a specific time. And we take that information and then build out a mathematical model that represents a decision policy. So for example, what's the best way to distribute food to several counties within the service region of a food bank, given the fact that the amount of donations that are supposed to come in at a specific point in time are not known with certainty. Other types of models that we build are computer simulation models. So we might develop a simulation, an agent-based simulation that represents a decision maker and might represent volunteers in an organization, and we try to mimic the activities that the volunteers are going to do in the organization to understand how the impact of not having enough volunteers affects the ability for that organization to function with respect to any activity. So it could be food distribution, it could be humanitarian relief, the cleanup, how volunteers are used after disasters, such as working in a warehouse and helping sort donations and also distribute donations. So those models, when you develop those models of those systems, then you can start to look at ways to come up with what's called heuristic policies for how volunteers, for example, can be assigned to different tasks, so that people who are waiting to either drop off goods or people waiting to pick up goods do not have to wait an excessive amount of time. And that excessive amount of time could be attributed to how volunteers are allocated throughout the warehouse during the process. So those are some examples of the types of models that students are developing here to try to help these humanitarian organizations perform their service activities in a more efficient and equitable way.